Hello guys, so today is the first series episode of Build in Public. So we intend to show you guys how we build Pennysia from scratch so that you can know the thought process and all the steps that make us achieve the production ready Pennysia. There are 3 components and 3 episodes in total. The first one is going to be AMM, which I'm going to cover today. So the AMM part will consist of 2 main things: the formula for the AMM and the oracle. So the formula we inspired by some protocol in the past, such as Curve and Solidly, that try to solve a stable swap. As you can see, there are 2 lines. The first one is in blue. It's constant, meaning that you are concentrated in the price of 1, but it doesn't allow the continuity, right? The token get depleted completely here. And then there is a Uniswap V2, the constant product curve here in the black line. And this thing, when we see from the bird's eye view or the concentrate liquidity point, you will get this picture where the liquidity is not concentrated, or it's provided from the price of 0 to infinity in the flat line. But when the curve come, the solidly stable swap come, they want to solve this by allow the liquidity to be concentrated in the price of 1 or 1% price point. And that is different than the concentrated liquidity that where we set the price range, because it allows infinite liquidity to flow whether to 0 or to infinity. You still earn fees, and you don't need to use third-party protocol to rebalance and make it in range. So now we are inspired by this kind of concept. But the thing is, there are different levels of concentration, where for stablecoin you might need to concentrate around 1% price point, but for the long tail assets you start to expand to this price point. And yeah, like EBTC might be in this, but for meme coin and other coin you may concentrate for this. And if you want to low risk and low reward LP, you may want to use this range of concentration. So that's the concept behind our curve. We want to build infinite market. We want to support different level of concentration while maintaining the curve, so none of LP will get out of range. And we allow fungible LP token. The concentration can be up to 10 levels. It's 1, 2, 3, 4, and 10. It's similar to Uniswap V2. And because of this, we allow LP to be fungible. It's gonna auto compound the reward, just like the UX in Uniswap V2. So it's easy to use and easy to get adopted. And for the pool fee here, it's gonna be a consensus between each LP, whether it is the in traditional markets, where one seller, one vendor may sell the higher price, another comes in and they lower the price, and people get buy, and then we average everything by the LP liquidity density for each LP, and then try to come up with the average mean fees. And the formula, it's easy, very easy. So that's X time y equal to k, this constant x plus y equal to k. So we develop 2 formulas here. We try to think 2 ways. One is to try to convert the constraint product here to the constant sum. You end up having this formula: x times y times x plus y power c. C is the concentration here level, and the k is the product. But this is very hard to solve because it's a monotonic function. That means you have to solve for k using the approximation loop over and over, and that's not efficient when the computation is done on chain. So we think of another way to solve this, which is think from the constant sum view and try to make the constant sum bend it to fit the curve of the constant product. So this way we get this formula: x power c plus y power c equal to k, where c can be anywhere from 0.1 to 0.99. So that allows us to support up to 10 level of concentration. So that's the first one about the formula. Next is the oracle. We want it to be resilient and fast. Fast also means cheap to compute on chain. So there are 2 kind of oracle: TWAP, time weighted average mean price, on chain right now, which is arithmetic used in Uniswap V2 and Uniswap V3 introduced geometric mean 3 TWAP, which is use a logarithm price instead of the raw price. The thing is that there's a good report, research paper from Delphi Digital that conclude arithmetic mean TWAP it's good when the price rising up because it's super responsive. But the geometric mean it's good when the price declining. Why? Because logarithm compress the price. So we want to find something in between these. So we can settle ourselves in the middle between these advantages between the two. So we use cube root instead. Cube root means TWAP, which is get us just a little bit less compression than the logarithm from the geometric mean. And next thing is, because there are 10 level of concentrations for each pair of assets, that means we can have like 10 pools for each pair of assets. And each pair, in traditional DeFi, each pool will consist of one oracle, which means 10 pools of it will have its own oracle. But these we want to combine all the 10 pools into one oracle. We unify them, so it's going to be quite more difficult to get manipulated. And next is we're going to talk about the LPM liquidity prediction market, which we improve it further from our hackathon MVP version. And the episode 3 we're going to talk about the value distribution. We saw something further. We adjust the VE33 model. So yeah.